Hello and welcome back to another Beyond Our Value. So this is a TimberHP monthly webinar that we do. We're back at the 1 p.m. time. So we're going to be actually diving into the very exciting guide for builders. So pardon me as I kind of get my bearings again on this new Zoom platform. So my name is Dan Edelman. I'm the sales manager. I cover the Mid-Atlantic, Midwest, and beyond regions. I'm also with a couple other TimberHP colleagues. So I'm going to actually go down the list to Edith. And Edith, if you wouldn't mind just doing a quick introduction.
Yeah, sure. Hey, I'm Edith Galler, the marketing manager at TimberHP. My background is in architecture and worked with one of the co-founders of TimberHP, Matt O'Malley at Opal Architecture. And so I had a big hand in bringing the Builder's Guide to life, along with Joe Stiebrick, of course, and Jason Todd, which I'll pass it over to you, Jason.
Thanks, Edith. Jason Todd, Director of Building Science and Industry Support. Certainly excited to share this guide and all the work that Dan's been doing out in the field, getting information out to folks, and a couple of other guests on the call today. Very excited to share the stage with some famous people from Maine. But mostly just really excited to get out in the market with the product and some help shape and form some of best practices that you'll find here in the guide and more documentation that we develop in the near future.
Yeah, and then next, the world famous Emily Mottram.
I'm not world famous. I'm just
Oh,
a
come
small
on.
town architect here in Maine. I'm going to keep telling myself that. Although I did write a little book called The Pretty Good House Book, and I get to really think about a lot of the environmental impacts of the materials that we put in our buildings and how we build. And so it's super exciting to me that TimberHP is both produced in Maine, where I live and practice, but also available on the East Coast. So for everybody else who is asking me questions about using it. So I am using it in several projects, including one with Randy. So
Awesome. Well, welcome back to the webinar also, Emily. And next we have Randy Rand.
Yeah, Randy Rand. I'm a builder here in Orono, Maine, also training director for Passive House, Maine, where we're focused on training builders and code officers and designers all across the state, trying to raise awareness on building science and pretty good building and passive house building and everything good in the built environment where all this TimberHP insulation, the vapor open assemblies are perfect for what we're pushing.
Oh yeah, in all climates, vapor open works. So this webinar really, it's something that I'm a big fan, and TimberHP is a big fan of just collaboration and education, within the industry. As you can see, we have an architect, we have a builder, you have the manufacturer. We really just like to come together every month and discuss whether it be a building science practice, a guide that we are releasing, some news, and anything else. During this, if you do have any questions, I was going to say and answers, but if you have any questions, you could just pop it right into the Q&A. We have Alexandra Hodges in the background. She's going to be relaying them to us, and we'll be able to actually answer them live. We do have a Q&A section at the very end of this, but if it's something that does make sense while we're actually discussing it, feel free to bring it to light and we'll actually go over it right then and there. So today we're actually going to be going over to, how to use the Builder's Guide, where to find it, how do you get it, all that. We're going to go over, kind of have a more in-depth discussion over just the control layers. And then we're also going to be talking, and what's very neat about the the Guide for Builders is actually the fact that it's climate specific. So if you're in Texas listening in, we have different details for that, and a lot of that is really just vapor control. But honestly, like I said early on, vapor open air tight works everywhere. That's one of the nicest things. You could be in Saskatchewan, Canada. You could be in Fort Myers, Florida. It's going to work very similarly in terms of vapor movement, or not the vapor movement, I'm sorry, it'll move opposite. But it's going to basically work very well for durable and energy efficient. I did want to bring up the fact that we do have TimberBat out in the market. We get, myself included, get a lot of questions about how to buy it and where to find it. So the biggest thing, we do have a dealer locator on our website, which is building up every single day. So if you saw it last week, it's probably different today. We're actually, selling through every lumberyard. Any lumberyard in the country does have access to the product. Our supplier is Cameron Ashley Building Products for the TimberBat. Or ask your installation contractor as well. So those are the two biggest avenues, but check out the dealer locator for that, or reach out to, your local territory manager for TimberHP or myself. And we'll basically guide you into the right direction of how to purchase the product as well. I've been installing it. It's been incredible. So first, I actually wanted to kind of pass it over to Edith just to kind of go over how to actually access and get the guide itself.
Sure. And we try to make it as easy as possible for you all. And I'm curious to know, so we have 20 attendees here, and in order to really focus our conversations as well, I'm just gonna pop a quick poll out there, and you can let us know what climate zone you're in. We have climate zone 1 and 2, 3, 4, and 5, or 6, 7, and 8. And so I will send
Ooh,
that
any
there
bets on
while
where most are coming from?
We got someone from
Yes.
Connecticut and Tennessee so far in the chat.
Great, nice. Okay, so in order to use the guide, you can pull out your phone right now and, and scan the QR code, or you can just go to www.timberhp.com, and then there's a yellow banner at the bottom of the website that says access the guide for builders. So that is accessible on the homepage of our website and this QR code here. You'll be prompted to enter in your email address, and you can opt into newsletters. And if you do that, you will also be updated whenever we update the guide, which is great because it is a bit of a work in progress. There are details that we are in the middle of testing right now. And so, yeah, if you want to pop your email address in right there, then you'll be the first to know when we have new details to share with everybody.
Yeah, and then you'll basically get a link, and I'm just going to click right on it. So then you guys could all see what you will get. And then I'm going to pass it over to Jason to kind of explain how the guide works and how to go through it.
No small task. We ended up with a very short list of things that we wanted to accomplish when we first started working on this project some time ago. And I think we've gotten very close to 80 pages, 70 something pages, and more that could be added to that. The wonderful thing about the builder's guide is that, it breaks things down by climate zone. And I think a lot of us, seeing some folks from right nearby here in Maine, but also farther afield as far as California and Chicago, and some passive house folks. We've got Blue Path and down in your neck of the woods, down towards Philadelphia. And everything changes in slight ways with really big impacts when it comes to best practices in buildings. And so we've got this broken down very much like many of the other guides that Joe Stieberg has produced over the years from Building Science Corp, for Build America, for state programs, same concepts. And so tried and true best practices based on building science, climate zone. You can see that we talk about control layers in the index, and vapor and thermal. And then there's much more, and we've done quite a bit of fire testing. Not all of that is in here, but some of that is. And the first half of the guide really breaks down the building science side of it, and more general best practices. Wouldn't specify things based on that first section, but you get into the climate zone and some of the nuance of all of that you would expect down the road when we get past these initial principles will be much more helpful when we talk about how it is we should think about wood fiber insulation, vapor open assemblies, and what we really need to do with those control layers that are specific to your climate zone. And like I mentioned before, we're really looking to add to that. I think that the team that we've got here has got a pretty deep bench of experience, and in addition to the friends we've got on the Zoom this afternoon, as well as farther afield with builders, with specifiers. Hopefully this is a guide, but more important, a conversation. I think that we've seen a lot of headway with vapor open assemblies over the years, and it's something that we really support. And you will find some below grade applications. Not all of those have been tested out and proven, but it's exciting to see. It does predicate or require that some other things happen. So I came from a retrofit world where we tried to fix the stuff that somebody along the way said, that's good enough. But over time wasn't. So it is a broader conversation of buildings, not all about insulation, but we like to be building science experts as much as we can. And part of that is really listening to others as well. So I'm very curious to hear what kind of feedback we get from the guide.
Yeah, I kind of wanted to start with Emily, actually. Emily, like now you're obviously a very well established architect that is understanding of this guide, but what are some of the things that you liked about when you kind of flipped through it?
Well, I think what's really important for architects is all the details, right? So I appreciate that you put it climate zone specific, as Jason was talking about, because one of the things about the Pretty Good House book that we got a lot of comments on was that all the details that we used in it were all Northeast based, which I understand. And so sometimes understanding how to extrapolate the building science for your climate zone isn't as obvious. So what I really appreciated is that there's a detail on here. It is showing me exactly how I can use it in my climate zone, or for me as a reference to people being able to just say, hey, take a look at this in your climate zone. This is how you would do it, right? So people were like, oh, I'd never build a double stud wall in my climate zone. Well, sure, you probably wouldn't, but this is 6 and we build them a lot here. So, paying attention to that. So this I really appreciate. As an architect, these are the details that everybody is looking for, right? They want to visually be able to see where does it go, how does it get installed, and how is it part of the system. So it's not just here's our product, yay, here's a picture of it. It's actually a physical detail that says, here, this is, and especially because there are a million different ways that you can do something, and so kind of narrowing down the details. And what I love about Joe Stebrick is he also tells you why we did it that way, right? And so you guys kind of import that in this, sure, there are 15 different ways you could have built this, but this is why we're going to do it this way, right? Everybody knows I'm famous for saying it depends. Every time somebody says that to me, they're like, oh, what should I do here? It depends. And so now instead of just saying it depends, I can say, hey, here's something that's really specific for your climate zone. This is an option that will work, that we know has paid attention to all of the other building science pieces that are part of it, because that's overlooked in a lot of industry stuff where it's not coordinated on what's happening for your specific climate zone. It's just, here's this product and here's how you could use it. So that's what I really like about the Builder's Guide.
Yeah, and I actually stopped on this one in particular. I know Jason, I saw him smirk when I stopped on this one, because vapor diffusion ports, that's something that I think is definitely, black belt kind of building science nerdery. And this is something that, as you can see, climate zone 1 and 2, especially when it comes to fibrous insulation materials like timber bat, timber fill on the roof deck, or underneath the roof deck. But this is something that's in the guide, which is actually very helpful, because this is one of the biggest asked questions is always roof assemblies. And all that information is actually in this guide. So, which is really helpful. And then like Randy, for a builder point of view, I mean, now this is less of a how to install, and we do have future plans of doing more installation kind of guidelines and whatnot. And we do have a bunch of videos for some of our products right now, for Timberfill, Timberbat, on our website now. But what do you gain out of this? I mean, you're also passive house guy, which I think also helps.
Yeah, I think the biggest thing for me was just that initial section, that principles was huge. In, a builder gets their hands on it, and now they can start to understand the background and the history of why things potentially get suggested, right? We're doing a lot here in Maine, obviously, with education and trying to bring awareness to energy codes and those type of things. And I think this knowledge here is invaluable. That is a great way to introduce builders to a lot of these principles of building science. So I thought that was a great introduction. But then to reiterate the emphasis on the climate zones, it's so useful to, many people, we get questions all the time about, hey, does this assembly work or whatever? And they found it somewhere in a guide, but it's like, well, no, you probably shouldn't use that in our climate zone. Where now, guys can quickly look at it and say, oh, I shouldn't even be, considering this. And it should make it easier for them to kind of, get on the right track up front.
Yeah, that's all really good points too. And I'm just going to leave this QR code up here for a little bit longer, just so you guys could all go on and basically get it. But I did want to kind of move the conversation into control layers. And, I'd say it's pretty basic information. But Emily, what is the most important control layer?
Water control. Water is the enemy of all of our buildings. And you would think that by this point in our building career that we would know how to keep the water out of our buildings. But I even got really interested doing some consulting on a project in Pennsylvania. And the homeowner sent me a picture, and it was leaking water in their window. And they were like, is this normal? Like, is this what I should expect? And I was like, well, no. Definitely not, right? And so then they show me kind of what's going on the outside. Turned out the flashing wasn't quite installed where it needed to go. And thankfully, they had low foamed around the windows, and thankfully they hadn't done a really good job on one of the windows, so they knew it was leaking. So this homeowner actually caught it before it became a major issue on all of the windows, because he wouldn't have known to call me back and say, like, hey, I don't think the flashing is done quite right. He just happened that in the rainstorm, there was a window leaking. So number one control layer, water control. If you do not manage the water in your building, you might as well not do any of the other things.
And where does that water control, where should that be in every climate?
On the outside.
Right. Okay.
The water control layer is talking about the outside water, bulk water, water off the roof, water coming in from flashing details, water from the ground. Like, those are all the things that we're paying attention to. I'm not talking about vapor and people breathing on the inside and other stuff. I'm specifically talking about weather and ground related water in your area.
Yeah. And then Jason, how about what's the second most important control layer?
I like this quiz because the answers are up there. This is totally good for me. As long as I got the answers in front of me, which is why I love books, by the way. And I think this is one of my favorite books right now. But I think that air control is something that's it changes a little bit where you're at or how you decide to get around to that. And I think of the stuff that we wear as our control layers. And so you can put a nice raincoat on, you can get the old nor'easter slicker, and then suffer with the air control and vapor later in all of that. But we can kind of look at some of the assemblies, being able to tackle all of these parts. And sometimes they're a little high tech, and we talk about Gore-Tex assemblies, and we talk about vapor management and all of that. And jumping ahead a little bit, but the most important thing is staying dry in the first place. And then in that assembly, how do you reduce some other aspects of it, and air and the next one, vapor, kind of go hand in hand oftentimes. So we can create Gore-Tex-like assemblies, and they do take a little bit of extra effort. But I think the important thing in all of these control layers, and what the principles section of the book really feeds into, is those best practices by climate zone. And now we're talking about the appropriate clothing that you don't necessarily have to spend too much on to be comfortable, to be energy efficient. And I think that's really the important thing when I start looking at all of those layers down the list.
Yeah, and one little fun fact too, air actually carries 50 times more moisture than vapor. So that's something, it's just the molecules much larger. And then Randy, I'm going to pass over vapor control. Oh, Jason, where should the air control layer be?
Well, I think it should be between water and vapor, looking at the list there.
No, I mean in the wall assembly itself, on the inside, on the outside.
Well, I think you can put it in a couple of different places, to be honest. I think in some places it's combined with other controls.
Or have multiple air
Yeah,
layers.
you might have multiple layers for that matter. And I
Mhm.
think if you look at some of the assemblies that maybe keep me up a little bit at night, below grade, because we've been not a below grade product. But if you look at that, we have multiple vapor control layers in there that also act to some degree as air control layers. And uh, I think I've seen air control layers on the outside, and I've seen air control layers in the middle of the wall sections, and sometimes on the inside, or some combination of all that.
It
Mhm.
depends.
It
I was gonna
depends.
say, I wanted him to say it depends.
I was gonna say that should be like the quote at the front of the book.
Yeah.
Yes.
And
And
what are
also, I was gonna say, I wanted to add to that is your air control layer is often multiple materials. People often ask me, what should I use for my air control layer?
Yeah.
The answer is it's multiple things.
Yes, yes.
and what are some of those things, Emily? I was just gonna ask that.
Well, some of those things, like super easy, concrete doesn't let air go through. So starting with your foundation might be your air control layer on the bottom. And then, moving up through your wall assembly, you could have if it's on the interior, a vapor variable membrane, right? Vapor plus air control, something like a Siga Myrex, or it could be on the outside as both a water control layer and an air controller like Sega My Vest. I think I got that right. My Vest is on the outside, my Rex is on the inside. Then window tapes and flashing and, all the way up to the top. There's so many parts and pieces to your air control layers.
Yeah, even taped OSB or plywood could be an air barrier.
Absolutely.
So, and then next up is vapor control with Randy Rand.
The biggest thing for me with vapor control is just thinking about how you're going to manage it, and making sure that we're allowing our assemblies to dry and not trap moisture into walls. So that's always my biggest thing when I'm thinking about the movement of vapor and understanding the different seasons that we're having, right? So and which direction it's moving during the different seasons and how we're going to manage it and throttle it and all those good things. But always thinking about things being vapor open and creating that positive drying potential.
Mm-hmm. And I'll ask you the same question, Randy, is where, and this is going to be more climate specific, where is that vapor control layer going to live?
It all is going to depend.
Yeah.
Climate zone specific. So, and it depends on how you're trying to manage it, I guess. So, understanding your assemblies is what we teach, and just understanding each component and how it affects another component is the background that we all kind of got to understand when we're putting together these wall assemblies.
100%. Yeah, primarily, it depends, but I'd say vapor control in the northern climate on the interior and vapor control in the southern climate on the exterior. But that could be, and again, vapor control, not vapor barriers, just so then the house could breathe or dry is what I say. Um, and then Edith, thermal control layer. What is some thermal control layers that we have available and where do they belong?
Sure, yeah, they belong, well, in kind of, they can also go in a multitude of
It
locations.
depends.
It depends. I mean, I think a lot of the assemblies that we're seeing these days, especially with in climate zones 6, 7, and 8, where thermal control and especially code is driving more insulation, we're seeing double stud walls, and so that would be kind of on the, maybe on the inside of the wall system. You're also seeing a combination of cavity insulation plus a continuous layer of exterior insulation, and in that case, sometimes the vapor and air control layer would be sandwiched in between those two layers, or the vapor control layer would be on the outside of the rigid board. So again, the guide does show a couple of different examples for this, and the really interesting one is when we get into roofs. And I'm gonna put a little bug in Jason's ear right now to talk a little bit about climate zone 1 and 2, and in this guide we do show that we have a couple of layers of rigid insulation in the roof assemblies for those warmer southern climates. And I want Jason to talk a little bit about thermal diffusivity and the thermal control layers that can resist heat gain in those warmer climates. So and wood fiber insulation in particular does a really good job of that. So yeah.
Yeah, I mean, I think that's a really exciting topic that I think a lot of us have had glimpses of over the years, depending on how many years you've been over. But I remember the importance of, I was not a builder at the time. I was in high school, but in the 80s, still interested in buildings and had friends with architect parents, or just progressive leaning in their building assemblies, or as a retrofit contractor going back to some of these places and finding problems that had been generated by what was considered the best practices at the time. And thermal diffusivity or heat delay is a really neat concept, and one that comes from the same concepts from the passive solar folks in the 80s and earlier, that thermal mass is really important. The kind of glazing that you pay attention to, Passive House totally gets this, and they've latched on to the importance of looking at orientation and all of that. But if you have a big thermal mass in your house, if you've got a big slab of stone in a greenhouse on the face of that southern exposure, you're going to get a lot of heat gain in that building, and that affects all sorts of things. It warms up the slab, the mass in that building. Not often do we talk about thermal mass or the potential to slow down or accelerate gains in a house when we're talking about the whole envelope and the insulation that's included in it. So if you look at the building envelope, as Edith was talking about in climate zones 1, 2, and 3, we can add mass to the building, and this is an adobe structure. So that's the traditional, before most of us here on the call and all of that, and generations of family, there were people here that were building structures like this in the Southwest and in the Mediterranean, and you can create this mass that absorbs all of that heat. Not because we necessarily want it later, although it does make its way through the envelope and then does radiate in to the interior space as the night air flushes out the heat of the day. And you've gotten that transfer of heat slowly to a point where now it's warming you when you might want it because it's a little bit cooler. But what's most important is that slowing down And wood fiber has a very high ability to slow down heat gains, much more than foam products or other fiber products that are mineral or petroleum-based fiber products, glass and stone wool. And in doing so, with a little higher density, a little higher capacity for taking on some of that heat, you can actually delay heat long enough so where it is in parts of the country, high warm temperatures during the day, but then a cooling period. If you get a good 20-degree drop, let's say, that's like a few weeks in July here, I think.
Maybe.
Might be a month or two in Arizona or some parts or something along those lines. Thermal mass or thermal diffusivity in an assembly really starts to create some impacts. And we're starting a second round of research with Oak Ridge National Lab on this. We're also looking at this with the DOE and the University of Maine in a wood structural insulated panel system using wood fiber. But that concept is you're going to slow down gains long enough to delay them to a point where cooler air comes in, and it then allows that heat to either reverse course because it's cooling out, and now the roof and the insulation on top of it is starting to shed some of that heat to the cooler night air, or maybe it's made its way through the envelope at that point, and hey, it's 60 degrees and feels chilly because it's been 80 degrees all day or 90, and you don't mind a little warmth at that point. Open up the windows, cool night air to flush it out. Real nice way of passively addressing, even in very conventional constructions. It doesn't have to be super insulated structure, but certainly helps even more if that's the case for roofs and for walls.
Yeah, and I'd even add to that it's not necessarily just climate zone when it's really hot outside, but also just the warm inside. And your walls are now being able to absorb some of that heat when it is really cold outside. So, let's say you do have overnight temperatures of -20, like when I go up to Minnesota, it's like that. But the walls are actually absorbing that. And then the next day the sun comes out, it heats up the wall, and it's able to actually move some of that heat back inside of the house. So I consider it thermal lag. That's the term I've always used. There's many different terms out there. I guess it depends on what term that you're using. Which I'm sorry to use that term so many times, but that's what happens. We do have a couple questions, not really questions, but comments in the chat that I definitely agree with. I guess we have some John from Alaska is talking about just having a warm garage. I know that like Minnesota, they do very similar. They actually put like radiant heat in the garages, and then you have very high humidity levels in the garage, which is also sometimes connected or attached to the house. And you do get some of those moisture loads inside of the house as well. So that's definitely something to bring up when we're talking to homeowners or people about heating garages. I personally have a detached garage. I think it's the best form, just keeping it completely as a separate building. But again, an old house also, I couldn't have a garage built onto the house. The next I kind of wanted to go through is actually the 2021 new climate zone map. And Randy, did you want to kind of go over the new map that we see here and how they kind of divided it up? And I would say some of the counties have actually changed to a warmer climate now. I believe Maine is one of those states.
So Maine is still in the same climate zones that we were in 2015. So we're still
Okay.
operating on 2015, but I have heard that many of the counties have shifted, especially in those states that it's county by county basis. Here in Maine, we've got climate zone 6 and then climate zone 7 for Aroostook County. And so we've got the two climate zones, but yeah.
Yeah, and then there's
I was gonna say, I talking with the other Randy Williams, I think it was, who is the other purple on the map. Like we've got way up at the tip top of Maine, there is climate zone 7. I think he said that we're experiencing that same thing as we move to those code cycles and they're adopted by state. There's sometimes some movement to temper it or adjust it to make it easier, which I appreciate because easier is better. But I believe that here in Maine at least, and also out in Minnesota, they're looking at kind of erasing that climate zone 7, which could lead to some problems because all of these ratios are about preventing the incidental airflow and the vapor or the vapor transported with it and the potential for condensation within that assembly. And Randy had talked about that of, where it lands and how warm that is, I think is really important, which is what the plus is on all of these climate zone breakdowns for walls and also woodwork for some sections of the code when we talk about ceilings too. How much insulation is above or towards the outside versus towards the inside will help reduce the potential for condensation issues in assemblies.
Awesome. Thank you, Jason. We did get a quick question that doesn't really relate to what we're talking about now, but it's one of the top questions that we probably get. And it's really just, and Jason, I'll kind of throw it your way because you're our building science guru. Can you share information about flame spread and fire resistance rated assemblies with wood fiber? I want to use wood fiber for multi-family buildings.
Yeah, great question. And just because it's on topic still, Juliet asked about the 0+ in this table. You see, this is new for 21, and it essentially is saying that it's always cavity first and then continuous after. So that means nothing in the cavity, which is what you would see in more commercial codes or following ASHRAE models of the overall U value of the assembly. There are another charts in the residential and commercial code that allow you just kind of add it all up like you would for a window. Gives you a little bit more insight on the actual effect of R value, but that is an option now in the 21 code cycle or some stretch cycles that you could just layer it all on the outside, which means you could have thinner framing profiles. You could use those as access as opposed to insulation. But I think it's a very interesting concept. I think it's also very thick outside that you end up with an R20. But some of the passive folks here would not be afraid, I'm sure. But
Oh, definitely not.
Flame spread and fire resistance, we have, I believe, Edith, do we have these broken down in the front or back side of the guide, little specifications on each one of our product lines?
I believe they're in the appendix at the
In the
very
appendix?
end.
You can also find that on the website. We've got a good deal of resources available on the website, but for flame spread and smoke developed, those are from a test called the Steiner tunnel test. It's E84, ASTM E84. It's a UL parallel to that. But essentially, it says, in this really long tunnel with fire applied and a little flow of air as well to feed that, how far would flame travel if we were to ignite this building product? And because of the primarily because of the borates and sometimes because of the density of the product, it will restrict that travel, that flame spread. For our timber fill and our timber bat installed in an attic application or in a wall application, we get a Class A fire resistance. It's a very low flame spread, a very low smoke development. And all of this is really relevant to the safety aspect of the code, which is, can we build structures that resist fire? In some cases, some building types, they have to be non-combustible. Those are types 1, types 2, and then type 3, which is like the multifamily building, could be semi non-combustible. I forget what they call it these days, but essentially it could be a non-combustible exterior with combustible things inside, and their heights are restricted. It could also be fire treated wood and sheathing. So you could essentially have a wood framed commercial considered non-combustible in all of that.
Mhm.
And all of those things, Class A fire resistance is written into the code. It's important. With our board product that's coming out, we expect to be in the market for residential with a Class B board, which means it would allow fire to travel a little further. But again, restricted to residential. This is the European model with the formulations that we're trying to emulate here in the States. And we'll most likely play with some configuration that gets us into more commercial projects. And I think the question was really around that commercial. So I think there are some avenues when we are first starting to produce board to get this into light commercial projects, height restricted, of course, until we do some further testing and find ways to make the board product in particular a little more fire resistant. The density of it right now is really what keeps it from traveling or creating flame spread that would be undesirable.
Yeah, and we even have current videos on that with Edith herself actually pulling off a
Right.
box that we torched with a flamethrower. So the big code that Jason was kind of talking about was NFPA 285. That's really going to be a very tall building when it comes to flame spread. It's an exterior creep test of fire that blows out of a window and creeps up the outside of the building and comes back into the next story above it. So that's kind of, it's an assembly test. So different ways to get there. But I think the bottom line is the products that we currently have on the market are Class A rated, and we have 1 hour and 2 hour fire rated assemblies available for that.
And the cavity insulation are Class A, and that's any building type. So if you have a cavity to fill in commercial, the bat and the fill are viable products, as well as the acoustic related products for assemblies.
Yeah. And I did want to go back to that +20 or all exterior insulation. I wanted to get Emily's actually feelings on that all exterior, and why is it, less than what the code for the total R value is for, R20 +5. Why is it less?
I was gonna throw this in the chat box, but then I thought most people on here might not be quite as nerdy as I am. But I'm teaching this in my sustainable design class right now, and how to actually meet the U factor in the code, right? Is that you have a percentage of your assembly that's framing, and you have a percentage of your assembly that is cavity insulation, or in this case, continuous insulation. So you are actually improving the whole R value of the structure when you put that insulation completely on the outside of whatever you have built your material out of. So you're actually making the non-cavity sections have even better R value than the cavity sections at that point, which is the opposite in traditional building where you only have insulation in the cavity and say you have a 2x6 wall. Well, everywhere you have framing, your wall system is only an R6 at that cavity. Or I mean, at that stud or piece of framing. So the way that you do that is you add all your R values, because your R values of your assembly can be added together. And then you convert that to a U factor, which is 1 over your total R value connected together. And then you take the percentage of your system that is framing and the percentage of your system that is non-framing, either continuous insulation or cavity insulation. And then you combine those together to get the overall R value of your wall system. So if you have continuous insulation, you actually have improved the R value or the U factor of the total wall system, versus if you have cavity insulation only, you're actually reducing the overall effective R value, which is why they're different. Anyway, if you want to learn how to do the math, it's pretty simple. I'm nerdy. I find this fun. It's pretty cool. Anybody who does energy modeling, your modeling software is going to do that for you anyway. So I use Ecotrope. I build out my walls. It tells me the total R value of my wall based on how much framing I have, how much cavity insulation, the 0.47 R value of gypsum board, right? So you get to add all those things together. So I like that the 2021 code is moving to you proving your U factor. I hope people understand that that number is the whole wall, and that they don't just use cavity, which is kind of the way that we've approached it before, which isn't really how the wall itself performs.
Emily, I feel like you're like reading my mind, because my next question was, what's the difference between U factor and R value? And you just answered it. So, and
So
the other question is, why are windows in U factor and walls are in R values? So nobody really knows.
Yeah.
Yeah,
I
the
mean,
U.
it's an assembly, right? A window has at least one pane
Mhm.
of glass.
Yeah,
You,
it's a
you
water
got a
barrier,
couple
an air
more.
barrier.
Yeah, but we've got layers and we've got different gases in between the layers. So there's a different value that you get out of that versus just an air layer. But then I believe that also is taking into account the the
Right.
sealant that holds that all together in the panes, and what kind of are you filling vinyl or not wood, because that would be solid, but
Mhm.
aluminum or whatever the framing itself is. And so there's so many different components. Always impressed when they get some super high, super low U values, high R values out of windows.
I'd also like to say that R value and U factor are reciprocal. So R value is telling you about resistance, while U factor is talking about transmittance, which I think is also one of the reasons why you see it in windows too. Is we're often thinking about how much is that window doing for transmittance as well, because there's more involved in it, where your R value in your wall system is opaque and resisting that heat flow. So um, they're not inverse; they are reciprocal. I
Mhm.
love to learn new things from Allison. You can listen to him talk about it.
Yeah. So then I have this great diagram of kind of what I call a split system. I think many people call it a split system. But Edith, did you want to kind of explain our, this is kind of our system that we like to promote?
Yeah, and it's really I'm really excited that we're able to provide a board product in our suite of wood fiber insulation products. So here you see, I mean, because of the reason that Emily just spoke to so eloquently, by the way, I learned of it
Mhm.
as well just now. Yeah, but just kind of acknowledging that a continuous layer of insulation is going to enhance the performance of your assembly exponentially. It's one of the easiest things that you can do, although Randy, the detailing is a bit of a hurdle sometimes, as I'm sure you've run into, figuring out how to detail a myriad of thicknesses of exterior insulation. But this sort of this assembly that you see in front of you is kind of like the baseline bread and butter wall assembly. So you have your cavity insulation on the interior, and here that would be the timber bat. The white line in the middle is your sheathing layer, whether that's zip sheathing or yeah, some sort of big board sheathing. And then the dotted line, and yeah, the two dotted lines are in this case your vapor control layer, or your hybrid vapor and air. Well, I guess the white the white line, the zip in this case could be the air control layer if the seams are taped, and then the dashed black line could be your vapor throttle, your vapor membrane. And as you can see, there are tiny little blue arrows that are letting little bits of vapor move through the wall system and exit to the exterior if need be. But you know, most of the interior vapor is able to enter the wall system and then exit back into the interior as conditions allow. Say you're in the shower and there's a high humidity in the air, the wood fiber can kind of absorb some of that humidity, but then after your shower is done, it can then re-release that back into the interior. And if it's just, if your bathroom is super humid for a long time and the conditions aren't really allowing for that back drying, then it can actually move through this vapor open assembly to the exterior and through our timber board, which is also vapor open, and exit all the way to the exterior. And yeah, does that kind of answer your
Yeah,
question?
and me and Emily, one of the things Emily didn't note is also, in addition to Pretty Good House co-author, E3 podcast. We just actually recorded one right before here, and one of the discussion points was moisture with like timber bat or timber fill. And we could hold actually 15% of our weight in moisture without losing any kind of R value. Also, the density, it's not going to lose its shape if it does get moist. I'm not going to use the word wet because no insulation should get wet. That's my rule. Especially in a wall cavity. If your insulation gets wet, you have much larger issues at hand than just your insulation being wet. Um, but yeah, so basically, yeah, the vapor drive, the vapor movement for here, it's a cold climate. So this is just showing that the vapor is actually able to move through the assembly without getting stopped, because when it stops, typically that's a phase change material, and that's what will cause condensation to occur. And that's where the ratios that we were talking about really make a difference. And it's dependent on climate as well. So in my climate, I'm in the Pennsylvania market, climate zone 5. Typically around an R8 on the exterior is kind of that magic number. You also want to look at aged R value. That's something that I always talk about. So there's no blowing agents in any of our products. So it's not going to lose R value over time, which is really spectacular. So a lot of these, foams and plastics, they actually use blowing agents, and those R values are actually going to decline as per manufacturer warranties themselves. Like polyiso is a 20% loss of R value. And with the foil facing is a vapor barrier. XPS will lose 10% of its R value. Again, that's just blowing agents, basically bubbles that burst, and the whatever gas that they use for that to get the higher R value actually off gas. So vapor open is really the way to go, and I'd say it's going to be. And Randy, I want to bring you back in as a builder, and for risk, vapor open assemblies. Would you say that they're less risky or more risky?
It's, as a builder, none of us are perfect. We're always going to have that instance where we're letting either bulk water in or making mistakes. And by having something that has that drying potential, it obviously reduces our risks, so that's why, one of my biggest things is making sure that our assemblies have that ability to dry, to reduce our warranty issues or our, potential issues in high, moisture areas. So
Yeah, very similar. I always consider it's almost like a hot water heater. How every hot water heater, or I'm sorry, water heater, not hot water heater, it heats cold water heater. Basically, they have a relief valve on the top or on the side of every single one. And same kind of thing with your wall assembly. You should always have a release valve. And by having this being vapor permeable, or the ability to dry greater than the ability of getting wet, is definitely the way to go for just an overall durable assembly.
Yeah, and in this example here that we're showing, if that continuous exterior insulation layer was not vapor open, and you did have a prolonged high humidity situation on the interior, you may start to get in trouble there, and that's where assemblies. We've learned a lot from insulating old buildings, for example, with non-breathable insulation materials, and that's a really quick way to rot out an old home or a new home.
Or a new home. Yeah.
Yeah. I could definitely vouch for that, Edith, because old homes, a lot of them did leak, like, I mean, massive amounts of air or water, bulk water. The materials back then were much more durable, I feel like, even the old growth lumber and all that. Now when we're insulating them, that's when the risk comes, and you still want to make sure that they could dry very quickly, because my house in particular had many bulk water leaks in it that we noticed after we started removing the siding and everything else. But we used all vapor open insulation, and I still feel peace of mind that if there is some sort of moisture, and I'm going to use moisture, not bulk water, it's still able to dry to the right direction of that wall assembly. So yeah, we're kind of at the Q&A section. I did want to go around. We didn't seem to get any other questions, but I wanted to kind of go to Emily and kind of, where can we find your work, and where can we, find more about you in general, or follow you, Instagram, whatever, how to reach out.
Absolutely. Plenty of ways to find me on the internet these days, I would say. Our architecture practice is Mottram Architecture, website mottramarch.com, which usually leads you to a bunch of the other stuff, which is the Pretty Good House website, which is both a book, a website, a concept, a something that we are doing a lot of speaking engagements on at different conferences. So definitely check me out at some different conferences. Representing women in the construction industry. So a little plug for a couple of women in construction events that are coming up, potentially here on the Northeast and out in Colorado. So keep up with me. I'll post information on that. I am somewhat active on Instagram and LinkedIn are my only two social medias that I actively will manage. So if you reach out to me on one of those two, I will probably answer you. Mottram Arc or Emily Mottram on LinkedIn. You can find me. And then, as Dan mentioned, we do the BS and Beer Show the first Thursday of every month live. I highly encourage people to come to the live show because the chat is often off the rails. There is so much fun and interesting stuff happening in the chat. We have a lot of people from the industry that join us that talk in the chat who will answer your specific questions. So it's a great time. But if you happen to miss it, I think there are over 100 episodes up on the BS and Beer Show's YouTube channel. So you can watch all the past episodes, which we have done everything from, super low BS 101 to some really in-depth building science stuff. And specifically, check out the latest one that we just did with Caroline Blazowski, who talked about water in our buildings. I think that's something we kind of take for granted about water quality and how that can affect us and our buildings. And not in the water control layers. We're talking about the physical stuff that we drink and put through our piping. And then the E3 podcast comes out once a month, and I'm doing some shorter sub 30-minute episodes this year because we're all busy and overloaded with information. So E3 Energy and Efficiency with Emily on all the podcast players, or you can download it from my website. Anyway, that's like a long list of places. I'm not hard to find.
You do it all. Thank you, Emily. And actually, I'm going to get to one question before I get over to Randy. Talking about the availability of products, is your dense packed product available? Yes, it is. So basically, you could reach out to your installation contractor. If they need to, they could contact myself. I'd say on the call here, probably just reach out to myself. I could put my number in the chat right now. I'll do that. But also, my email is just dan.edelman@timberhp.com. And then I'm going to go over to Randy. And the way that I always like to ask Randy this is, Randy, how do you find yourself?
The best way to find out what we're doing is head over to passivehousemaine.org. You can see all our trainings that are scheduled. We have all kinds of live events, site tours, lecture series that are all happening. Great place to share information and just talk with. There we go. Another Superman.
I was wondering what was happening. I was like, it's not that kind of show yet.
Yeah. So yeah, passivehousemaine.org. You can follow Passive House Maine on Instagram, Facebook, LinkedIn, all that type of stuff. So we're always doing some pretty cool things with the building industry. You can find me personally and follow along with some of our projects at randy.rand_arhaus on Instagram, and BS and Beer Orno on Instagram. So that's where we're most active, and try to keep information and cool things happening in the industry.
Yeah, and one last thing is BS and Beer Philadelphia. I will be there tonight. It's our first meeting ever. Thank you to all the BS and Beer folks. that helped us out in Philadelphia, kind of getting this thing to be an actual event. So we're going to be at Workhorse Brewing down in I call it Chuck Norristown, but it's Norristown, Pennsylvania. So you could come there. It's at 5 p.m. to 7 p.m. there. Randy, I did have one last question for you. What size fasteners did you use on your roof with 8 inches of continuous insulation up there?
They were 16-inch screws up there. Yeah, that was fun, Dan. I always appreciate your help putting those in.
Oh yeah, that was fun. I think when I asked you first, you're like, "Oh, these are like 6-inch screws," and it was like
These
a
are about
16-inch.
6-inch.
So,
It's the
well,
fishing
thank
one.
you.
The
And then
unexcited
Jason,
part.
oh, Jason, how do you where are you? You're on Instagram.
I am. I think a lot of us here at TimberHP have professional handles, first name, last name, .timberhp or some version of that. Jason Todd dot TimberHP, I think is the Instagram, but you can usually find me following Dan.
So, and how about you, Edith?
Oh yeah, I'm just wrapped into the general Timber HP company wide social channels, but definitely if you haven't already, sign up for our newsletter and you'll be abreast of the new updates that are coming out, and also additional workshops like this one that are coming up. And we haven't populated it yet, but we have these Beyond Our Value continuing education webinars monthly. We will soon be populating the website with a bunch of other ones coming up this summer, but usually they're the third Thursday. Is this the
Yep.
third Thursday already? Oh my gosh, how did that happen? And so yeah, we'll be talking about lots of good stuff coming up. So keep your eyeballs on that as well.
Yeah. Well, thank you everybody for joining today. Thank you to the group of panelists that we have on, and I'm sure we'll be seeing them again. And I guess till next time, guys, we'll talk.